Yep.
Yep.
All right. Thanks. So, okay. So the idea of this session is to bridge the gap between KiCAD and Flux. So basically try to let you guys know the workflows that you're used to doing in KiCAD, how to make them work in Flux. So by the way, if you have questions, just line them in the chat. Either Kerry or Lance will answer them right away, or I'm going to do a few recaps during the presentation to answer if there's one question that it's held by many people or interesting questions. I'm going to address those during the recaps. So as I was saying, I'm going to try and bridge the gap between KiCAD and Flux and teach you the workflows that you're used to already using KiCAD. How do they translate in Flux? So the very first thing that you already experienced is that one of the main differences between Flux and any other tool, Flux being web-based, is that you can basically share your projects with anybody with just a URL. So if you set your permissions right, and then I'm going to talk about how you set the permissions right later. If you make your projects public, just by sharing the URL, anybody will be able to see the project. You can set your permissions to see, edit, or just comment. But basically, yeah, just sharing the URL will work. The second one is your profile, which is what you're seeing here. This is my profile, has the same properties. So you can share your profile's URL, and then that kind of acts as your sort of CV or portfolio. We actually even have people in the Flux community that got reached out to, like seeing if they were able to do contract work or work for someone else, just because that other person saw this guy's profile and all the projects that they did, that he did, and so on. And so it can definitely act as a portfolio. So let's sort of do the first thing when we open KiCAD, we see a screen. I'm using KiCAD version 6. So this is what you kind of see the first thing that you log into KiCAD, and you already start seeing some differences between this and Flux. So the ones that I just mentioned are ones, but also you see that KiCAD has different tools for different purposes. So you have a schematic editor, a symbol editor, a PCB editor, a footprint editor. So there's one tool for different purposes. And that sort of has the side effect that you have a bunch of different types of files, or a bunch of different file extensions. You have KiCAD PCB, KiCAD schematic, symbols, KiCAD mods, and libraries. And you even have a library editor in KiCAD. So there's like one of the main differences is that in Flux, we only have one tool for everything. And this has sort of deeply rooted consequences. I'm going to talk now about those. So going back to KiCAD, again, you see there's no different tools. I mean, there's no files and file extensions because it's web-based, and you just share the URL. But also there's no different tools. So let's open this project that I have here, just an example project. Now, the first thing that we see here is on the left, we have a library. This is kind of like one of the biggest differences. In KiCAD, you're used to having many different types of libraries. So you have global libraries, project-specific libraries, you have your own libraries. You can download libraries or clone them. There's all different types of libraries. In Flux, there's a single library, the one that you see here on the left. And in this library, you'll be able to see any part that you have access to. And what that means is you'll see all your parts, of course, all the parts that you've created on your own, but you'll also see parts that some other people created. and you'll be able to see other people's parts if they make them public. So here on my top right, I can have I share dialogue, and then I can decide what type of permissions I give people for my parts or projects or whatever that is. So if people make their parts public, you'll be able to access those parts immediately from the library. There's no different libraries, it's just one.
Can I interrupt? Hi, Brooks here. Sorry, Nico. Just so that everybody knows, every new project that you create in Flux by default is private automatically. So you sort of intentionally open it to other people. Okay, so your privacy is preserved in that way. Sorry for interrupting, Nico.
No worries. Yeah, so it's an active decision, right? If people decide to make their projects public, they will be public. If they don't, as you see here on my project, it will be by default private. Also, you can share your project or your parts with specific people. So if I go to share and then advance, I can share only sort of my parts or my projects with only with specific people. So again, like this library will show you every single part that you have access to. Again, either because they're public or because someone shared it with you or because you created them. So that's a big difference between library management in Flux and in KiCAD. In Flux, it's a single library. The main benefit, I mean, there's a bunch of benefits. One is that we really encourage sharing if you're comfortable, like sharing parts. Like there's thousands and thousands of parts in the library now that are ready to use, made by some other people. And then the second benefit is, again, when you're sharing a project, there's no like this problem of like you share the project, but you didn't share the library. So whenever someone opens the project, it's half broken or parts are missing or stuff like that, is gone. Because when you share a project, you share access to the same library that the library is saying. So in this case, that's a major advantage when you're sharing either projects with the community, when you're wanting to have design reviews. So basically you go into a community chat and then you share your project to get design reviews. People will be able to see your project without having to download like libraries or you sharing your libraries or having the risk of having your projects broken. And then the other main difference, and this is a pretty substantial one, is the way parts and footprints work. Now, so in KiCAD, what you're used to is having, so your project is one thing, your symbols are completely, let's go back here. Your project is one thing, your schematic, your symbols are a different thing, different file, different extension. Footprints are, again, different file, different extension, completely different thing. And then there's this concept of assigning footprints to symbols or assigning that netlist to a PCB editor. So these are in KiCAD kind of disconnected concepts that you need to link manually. You link you sync a footprint to a symbol, or you kind of sync a PCB to the schematic project via the netlist. In KiCAD, or in Flux, all these are completely interconnected. So you can see here that there's a schematic and there's also the PCB for my project. There's no there's no look, I need to assign that list. They're completely automatically interconnected. So let's see how that works for a part, which is one of the things that KiCAD users and something myself get confused by, like when we first try to use Flux. So I see a resistor here, right? A good old resistor. Now I can open this part. So basically I'm going to be going inside this part in a different window, as in a different tab. So when I open this part, the first thing that I will see, it's something that you probably find confusing, right? It's like, oh, but wasn't that a resistor that you opened? how come there's two things here. There's no resistor. Now in Flux, we have, and you'll learn how powerful this is when I in a few minutes when I share the other example. But there's a different concept between the outside symbol, what we call symbol, which is the way you see a part when you place it in a project, versus the internal schematic of that part. Again, if you go inside a resistor, what you're going to find is that there's nothing inside a resistor. It's just the actual composite material that causes the resistance, right? So in Flux, what you see is just the two pins, or what we call them terminals, which represent this part. So a resistor has only two pins, so only two terminals. And then on the PCB, you immediately see the footprint. It has two paths, one per terminal. So each terminal, when I grab one terminal from my library and then drag it to the canvas, I'll see this. And then immediately I'm going to have a path added to the PCB editor. Now, I was saying that this is going to make more sense when I share the next example. Now, again, remember the symbol is, let's say, the external representation of a part, and then the internal schematic, in this case, is just two terminals or two pins, because the resistor only has two terminals or two pins, or two paths. Now, let's try this other part that I have over here, this micro SD slot. Now, if I open this part, what I find is that this is not the terminals that I just found. This is something different. Now, this is what in Flux, what we call the sub layout, or sub module. So what happens is that you can actually nest, and for all intents and purposes, a sub layout acts as a part. So if you go back to the project, it really is a part. Like, it has the pins, the symbol, but when you go in, it's actually a small little project. And seeing the PCB, you'll see that it's a full layout. So it has two resistors or two capacitors, the SD connector, and even traces. And this is the exact same thing that you see when you go to the PCB. You see the same micro SD connector with the two capacitors. Now, what this allows us is to not only create parts, but also create reusable sub layouts. So this is already laid out. I don't need to put the resistor and the capacitor next to it, routed. When I use it on my project, it's already done. And you can nest as many things as you want, as many levels as you want, right? I can, for example, if I go and open this one, this is actually just a part, right? When you open a component or a part and you only see the terminals, that's kind of like the end of the way. There's nothing inside there. The terminals are the kind of the main, or the atom, the basic building block. So this is how parts and sub layouts work in Flux. It's different to what you're used to, but the idea is that the good thing is that it's very powerful. So you can add as many sub-modules, yet another sub-module, and then basically you just grab and group 2-3 big modules, and you have half of your design done. Okay, so let me do the first recap and stop point here. I'm going to quickly recap what we just learned, and then Carrie, if there's any questions, feel free to raise them. So what we learned was it's easy to share. So just basically just by sharing the URL, if you set your permissions to public or to the person that's going to be viewing your project. Just by sharing the URL, that person is going to be able to access your project. The main first difference, there's no files or file extensions in Flux. Everything happens in the browser. There's a single library. There's no concept of global library, per project library, or anything like that. I'm going to quickly, like in the next section, quickly go over how you can filter projects, find parts, etc. But the idea is that you only have one library that guarantees that whenever you share a project, it will always work completely. And then second difference, you don't have footprints on one side and symbols in another side in Flux. They are one thing. And what that allows us is to A, simplify things, and B, be able to nest sub layouts within each other. And then when you use a sub layout, it's basically a bunch of parts already laid out that you don't need to, that basically jump starts or kickstarts your project, right? It's already done. You just drag it and then connect it to something else and you're good to go. So I don't know, Gary, if there's any question that
yeah, there's some interest in version control in the chat. Can you talk a little bit about how Flux does that?
Okay, yeah. So basically, version control is it's built in. So it's not something that you enable or disable. It's kind of like how it works if you're used to using Google Drive, Google Docs, or something like that, where every single change that you do is automatically saved, and then you can go and then go to the change history menu, and you see all the changes that were done to this project, basically from beginning of history. And then at any point you can go and click and then restore that that version, that specific version if you want. If you restore that version, what you're gonna see is a new change being updated, saying that the project has been restored to that version. And then, of course, even that step can be backtracked. So you can go back and say, no, I don't want to go back to the version. You go back to the original state. Every single change on any level, schematic, layout, anything would appear as a new version. Here's the version number. So that you can roll back to a previous one.
Awesome, that's a great summary.
Yeah, again, just it basically works very similarly as it works on like other web-based tools like Google Docs, and so on and so forth.
Yeah, the whole like Russian doll nesting concept of Flux can be kind of new to people. I wonder if there's any questions around that, or maybe it just makes perfect sense and you guys are like, fantastic, finally, no further questions. I will take your stunned silence as awe and acceptance.
All right.
Okay, Nico. Yeah, let's keep rolling. If there's thanks, Gabe. Thanks. Gabe gives us a silent applause. If there are more questions, drop them in the chat and maybe we can just keep on rolling.
Yeah. And again, I'm gonna do another recap in 10-ish minutes. So I'm gonna address the questions when we get there. Okay, so next thing, so I'm gonna quickly talk about the library and how you search for parts. And then I'm gonna run an example of creating a part to show you some other interesting things about Flux and what the difference is between Flux and KiCAD. So in the library, when you type something, you'll see all the matches for that specific, of course, text that you're looking for, searching for. For example, STM32, you have, as I was saying, many thousands of parts in Flux already, and STM32s you have, if not all of them. But you can also filter by a few things. So you can filter by if the item is yours, so only parts that you created or that you own. Items that you've starred. So we will only show you items that you've starred. You can go open an item and start it if you want, in this case. And then parts that have footprint, I usually recommend that, like when you're starting out with Flux, that you keep this option enabled. I mean, Flux will tell you if you've added a part that doesn't have a footprint, but in any case, it's always better to just have this on and then filter by footprints, but parts that have a footprint in most cases. Or you can filter by sub layouts. So basically not parts, but complete sub layouts. So if I drag this into my library, what I'm dragging is a complete sub layout, not just a single part. And then also if the item has or doesn't have a simulator model so that it can run the simulator, something that we can discuss at the end as well, the simulator a little bit, or if the part has a 3D model. So if the part has a 3D model attached, it will be a match. If it doesn't, it won't. That's quickly the library. Now, the next thing that I wanted to quickly discuss is, so in Flux, again, most probably you're going to find everything you need in the library. If you don't, you have a bunch of options. One is either find a part that is similar. For example, let's say I want to create a diode, and that diode is very similar to this diode. The easiest thing would be to find a similar part. I can go here in Flux and then clone the project. That what that does is basically creates a copy that I own of that project. And then, for example, if the change is very small, or basically the footprint is the same, but I actually had one that, see, that's why you should always have stuff with footprints, because I chose one that doesn't have a footprint. But let's say that the footprint of this part is exactly the same as the one as you need, but some of the properties are not. We can clone the part, just edit the property, and then you're going to have one part. So this is a difference in workflows than what you're used to do in KiCAD. So in KiCAD, what would you do? You would create a new symbol and then link the same footprint to the new symbol that you just created. In Flux, if you already have the footprint somewhere in the library, what you can do is go to the part, clone the part, and then change the part number or something. For example, let's say that I want to have a another transistor that has a TO92 package, right? So if I open this one, what I can see is that it has the TO92 package, but it doesn't have any manufacturer part number, right? What I can do, instead of creating a new part, I just clone this one and then add the manufacturer part number. As soon as you do that, another interesting thing about Flux being web-based is that as soon as you add a manufacturer part number, Flux will automatically search in the main distributors, Mouser, DigiKey, and LSC PCB for that part, and then tell you availability, pricing, if it's ready to ship, and so on and so forth. So again, instead of creating a part, you find the footprint that you're looking for, you clone it, and then you just change the part number to the one that you want. Okay, so let's quickly run through the example of, so if none of this works, so you didn't find the part in the library, you didn't find a part that was similar, actually exactly the same footprint or similar footprint or something, is not, you don't find the same part, you'll need to create one. I'm going to do a very, very quick example of how you do that. But after the presentation, I'm going to send you guys a link to further tutorials on how you can create parts, add 3D models to those parts, and do all sort of things. Here, I'm just going to do the quick the quick example just to show you something. Now, as I was saying, Flux allows you to import KiCAD parts. It basically allows you to import complete libraries. So if you have a library that has a bunch of symbols, as soon as you open it, you'll see all the list of symbols. This library only has one symbol, so I only see one. But if it had thousands, I will see all the list here, and I can import everything in one go. So if I import this part, what I get is a new project with the name of the part that I just imported. I automatically get the symbol. So basically the external representation automatically imported from the KiCAD library. Since it has a manufacturer part number, I automatically get all the pricing and availability for that part. And then since I imported a part, I have 3 terminals. And this is the other main difference that you see in Flux that you don't see in KiCAD. So in KiCAD, when you have a schematic design and you want to create PCB for it, you need to create a netlist and an ECO, and then link the two. In Flux, as soon as I do changes on the schematic, I will immediately have those changes on the PCB. So I added 3 terminals, and then I'm going to have 3 paths automatically added on my layout. Now, I'm going to, so what you see here, like the other detail here is that you don't have the footprint, right? So I imported all the symbols, in this case, 1 symbol, but I don't have the footprint. The way to import a footprint is you need to go to the panel on the right, scroll all the way down to the bottom in the assets menu. This is where you load external assets. This is where you load, for example, the symbol. By default, Flux creates just a square. But if you add an SVG file with a better symbol, you add it as an external asset. Now, as soon as I add my KiCAD footprint file as an asset, what I need to do, and this is I'm gonna talk about what a rule is in a few minutes, but just to close this chapter of parts, the way to make sure that you link the footprint to the asset that you just added is you click on the footprint, go to the objects menu on the left, click on the footprint, and then you add a rule to that footprint that's called asset. And then in the box, you type the asset that you just, I actually moved this one, but if you don't move it, it will appear in the right place. So if I added the asset, the ID of the asset is TO92, and then you go to the footprint, add an object-specific rule to that footprint, a rule called asset, and then you type the same ID of the asset that you added. And this is how you import parts from KiCAD. If let's say that you have your own library, you don't find all the parts of your library in Flux, this is how you can quickly add them. So before
you can also do it from scratch. I'm sorry, but you can, if you want to, right? You don't need to do all this asset importing and application, whatever. You can just go to the data sheet and create everything as you please. It's obviously going to be a little bit slower, right? But the option's there as well.
Yeah, I mean, so if you add all your terminals, basically, if you create a new project, you add a bunch of terminals to your schematic, you go to the PCB, you're going to see all those paths, and then you can rearrange them as you want. You can make them through holes, SMDs, whatever that is. Yeah, you can create the parts on your own. It's usually easier if you already have the part created in KiCAD. You just add the asset and everything is done automatically. But yeah, you can create parts from scratch if you wanted to. So before I move on to quickly discuss PCB layout and a few of the main things that you need to keep in mind. I'm going to do a quick stop here, and then recap and carry again. Let me know if there's any questions. So what did we just learn? There's no syncing between, there's no assigning footprints to parts in Flux. The only concept is the concept of assets, which are basically external assets to that part that have a specific behavior. So the same way you add a footprint, you can add a 3D model, you can add a symbol. So basically, to add other properties to this specific part that will make them will make it closer to what it needs to be. And then usually the process of, before you actually try to create a new part, what you should try to do is first find in the library. If it's not there, most probably it's going to be another part that is either very similar or even has the same footprint. If you find that, you can clone that part and then change the part number, and you're done. If none of that works, you can create your own part. And then the last step, when you create a new part, the last step to actually find it in your library, is that you need to go to the Flux menu and then publish to library or publish the changes. This basically makes this part available in your library. Since it is a private project, I didn't make this public. It will be only me who sees. So if I look it in my library, this is the part that I just created. Again, if I make this public, if I go to this part and then make this public, anybody else will be able to use the part and not just me. Which is, I mean, we usually encourage people to do that, but you have the option, it's even the default. By default, the part will not be public. Only you will be able to access it, but you can decide to share it. Right, before I have 10 minutes for the PCB layout, is there anything, Kerry, that I should, any questions that we should address?
Yeah, I think you covered most of them. There was a question about publishing, which you just walked through. And then there's a question about the parameterization of parts. This is relating to coming from Fusion 360. I don't have enough context to answer that question. Do you know more about what that process looks like?
What was the question? Can you repeat that?
Yeah, let me find the original question.
I'm pretty sure the question is like, can you have parameters that you're able, like variables that you're able to use throughout the project? So you define the variable in one place and then you reference it elsewhere. Am I nailing that?
I think this is from Travis.
Yeah.
So there is a concept of, I haven't got to that yet. And I'm gonna make sure that I send you the tutorial for that, Travis later, so I don't go deeper into that. But yeah, you can. So for example, let's say that you have a few properties here, like the part number that you set for this part. In the layout or in other properties, you can actually use formulas. And for example, if you put equal, you can access other properties, sort of.
Wait, what? We ship that? Are you kidding me?
Yeah, there's a few properties that you can access. Yeah, not all of them, but yeah, most of them you can.
Wow, dude! All right, thank you, Travis.
So I'm going to send you the documentation for that, so I don't because it takes some learning. So I don't disrupt the whole presentation. I'm going to make sure that I send you the right pointers after the call.
Travis also had another question. Are those assets used in ERC?
In what sense? I mean, sorry, let's go back to this project. I have a few DRC examples here where I actually don't have any problems. Like I'm not sure how that
Oh, rules check. Oh, yeah.
What the question is. But yeah, like if I add an asset that modifies the part, for example, it creates a different type of terminal or pad and then positions it differently. If that affects my design and puts things where they shouldn't go, for example, they collide with each other, I'm going to have a DRC saying, hey, you have a problem here. Two traces are overlapping. So yeah, like basically what you see is what you get. If the asset modify the footprint, that's what you're gonna see on the PCB. And if it is a DRC violation, you're gonna see it.
Can I try answering it in a slightly different way? Assets. So the fundamental way that we think about PCB layout is with this language called rules, which is like sort of like a CSS language. And what an asset does for a footprint is it's a quick way to write a bunch of rules. So we take the asset and then we like apply that and we translate into rules. And so then the great part about that is then our design rule checker just checks for if any of those rules are wrong. And it does that live all the time, as opposed to like you having to run something at the end. You can open up the feedback drawer that he has open here, and you can see all the rules that we have available. It looks like there's only 3 right now, and we've chosen to surface those because we are starting with so few. We just launched our DRC so that you always understand, what does it mean when we say you have 0? What does 0 actually mean? Well, it just means that these 3 are negative, right? But in the future, we'll have many more. And yeah, but that's it. I hope that answers your question. Yeah, great. Thanks, Travis.
And I'm going to actually talk about rules in this last 10 minutes. So to introduce you to the concept that Brooks just that was referring to. So this is another. So there's a related concept in KiCAD, which is properties. This is something that many people find confusing in KiCAD when moving to Flux. So in KiCAD, when you have, let's open quickly a PCB. If I want, for example, to modify the position of this PCB, of this footprint, sorry, what I do is I open the footprint properties. And then in the properties, I edit the position of this footprint or the orientation or whatever that is, right? In Flux, properties are on the schematic. So properties are, for example, what you should call as parameters, like manufacturer part number or manufacturer or whatever, the designator or the data sheet, things like that. So those are properties in Flux. They belong to the schematic. And the PCB properties we call rules. And that's how you modify the behavior of schematic components, of PCB components in Flux via rules. So let's put a quick example here. So let's see that I grab my layout. So what I see here is object-specific rules, which basically are, if you're coming from KiCAD, properties for this layout. So in this case, again, if you go to Edit and Add, you will see all the different rules that you can add. And you're going to see many of them are familiar, like position or rotation, whatever it is, rotation, right? Like all those are what you usually call properties when you're coming from KiCAD. Here again, in Flux, they're called rules. So you can add as many as you want. And then some rules make sense for some objects. Some rules make sense for all objects. For example, trace width, the trace width rule doesn't make sense for a layout. So if I add I'm going to trace width rule to my layout, it won't do anything because it's sorry, there's another concept that I picked the wrong rule. There's another concept in rule. I'm going to also share the documentation just call it inheritance. So the layout, you see that has a bunch of components that depend on it. So all these components, all the nets, and all the traces are inside the layout. So when I add the trace with rule, you can see that it says inheritable, yes. So what it means is that all the objects that depend from the layout will inherit this rule. So if I add a trace with rule, while it doesn't make sense for a layout, so you see compatible objects is only traces, since all the objects will inherit it, basically every single trace will have the trace with that I just said. But if a rule is not inheritable and it doesn't make sense for that object, then nothing will happen. So going back to this, you add rules, and with rules you can edit all these different properties of the object, like the size, or the corner radius, or the stack up in the case of a layout, and all this. And then same thing goes for if I want to add, if I want to edit traces. I can go to either these tracings in particular and then add a trace with rule, or I can even go to the net and add a trace with rule. And this is another part that you have on KiCAD. Usually the way you do this in KiCAD is you define a net class and then you assign a property to that net class. In Flux, the easiest way is you go to the net object. You can even rename that if you want it. Let's say that this is VDD. I rename the net, and then I can add a rule. I already added it. A rule is trace with, and I can modify. And then every trace, see, on that net will get this new value. Again, trace with is inheritable, so it means that all the children, so every single element that is inside the net, so it's all the traces and the vias, will get this rule. And this is basically like one of the last, depending on the time we have, I can go deeper into some other things. This is the last thing that it's different in KiCAD than it is in Flux. Again, when in KiCAD, you define a net class, and then you assign a trace width to that net class. In Flux, what you do is you find your net, and then you add a rule to that net, in this case, trace width. But it can be the same with spacing between traces, or minimum width or maximum width. All these rules are available to use for in this case, nets. So I'm gonna do a last recap, and we just have 10 minutes, so we're gonna answer questions that people have. So what we learned about PCB, the PCB editor. So the first thing is that there's no concept of netlist or ECO. Whenever you make a change in the schematic, it immediately happens on the layout. So for example, let's actually delete this. As soon as I do that, boom, it's gone from my layout. Okay, remember that you can go back in history if you want it, and I mean, you can Control Z and redo that change, or if you did a few other things after, you can use the change history menu. The other thing that we learned was the concept of rules, which is similar to the concept of properties in KiCAD, and properties are in Flux only for schematic. So properties are parameters, similar to parameters, where you can add, again, manufacturer part number, datasheet, distributor, like whatever, like all the parameters that you're used to adding to parts. Properties in KiCAD are called rules in Flux. They're much, much more powerful. You can basically do everything with rules. You can modify every single behavior of the PCB. via rules. And then this is a quick, something that we usually ask a caveat. We know that editing everything using rules is kind of like big overhead, but one by one, we're surfacing different UX elements, and Bruce can talk about that later. We're surfacing different elements that would basically are shortcuts to rules. So rules are the way that the backend of Flux works. Like everything is a rule at the end of the day. What we're surfacing with all these menus, like flip layer or a shortcut to trace with or align things, basically what they do is they create the right rule that makes that happen. For example, if I I grab a thing and I flip it from layer, what Flux does in the background is it creates a rule that basically changes the layer to inverted. That's what Flux does in the background. When I change it to trace with this menu, what Flux does in the background is creates the rule trace with in the science the way that I just told you to add. And yeah, that kind of covers it. Like these are the things that I absolutely had to discuss. Let's do some questions, and then I have a few other things sort of as a bonus, depending on how we're doing on the time.
So I'm just going to read this one from David. Is there documentation on how to find, use, and modify the various assets needed to create a schematic in PCB? So I think that would be mostly our documentation page. Do you want to demo that quick, Nico?
Yes, let's do that.
Well, look, we should clarify the question. Hang on. We should just clarify this, right? So like, first of all, there's two ways to create a part in Flux. The first we've seen is basically importing your existing KiCAD work. So you've already done the footprint in KiCAD and you want to be working in Flux. Great, we got you. Just pull it on in. Bingo bongo. The second way is you get to create stuff from scratch. So I think, you know, the essence of the question is how do you modify assets? Those assets are modified in whatever program you're migrating from. Does that make sense? And if you don't want to use assets, you don't have to, right? You can absolutely create from scratch, right? Once you drop a terminal on the schematic, we create a pad for you. And you can go put it in the right spot. And you can make more pads and silk and do it all from hand. It's all good.
Yeah, so I think that covers the part aspect of that. I think there's also a question about combining those things into schematic and PCB. Yeah, so doing these things from within Flux. So are you talking about sort of like, how would you start a schematic from scratch, or how would you create the layout?
So I can quickly show that while whoever asked the question maybe can clarify what they intended. But yeah, you can create a new project. I mean, there's a few things that you can do. You can create a new blank project, which basically has, as the name says, absolutely nothing on. So there's nothing schematic and nothing on the PCB. There's nothing. As soon as you add something, you will see that on the PCB. What we usually suggest that people do is, so if you go to your profile, you can search for templates, and then you're going to find templates for many different projects. You find Arduino templates, Raspberry Pi templates, part templates, a bunch of different things. If you find a template that you like, for example, whatever this Arduino MKR template, you go here and clone it, and then you have a bunch of work already done. So you have all the layout done, yeah, the shape of the layout, all the headers and all that done, which is much easier than doing it from scratch. Or you can go here to the Explorer page, feature projects. There's a ton of other projects there. here in the feature projects, you can open a new window with a bunch of other projects. So I don't know if you've got any.
Do you want to just screen share over to docs.flux.ai just to show people that that's a thing? That's, yeah, there we go. Hey, look, there's our docs, just docs.flux.ai. And then I'm hoping that, David, this answers your question of like, well, how do you alter those things once they're in there? It's actually pretty straightforward. Yeah, I wonder if that answers your question. I gotta bounce, guys. Thank you for coming.
I don't know if there's any other.
We're just going to start dropping some links in the chat. So there's a couple of YouTube channels. There's an official Flux YouTube channel. There's also one called Overshoot, which has a bunch of really helpful videos that you can use in addition to these docs. And then if you can't find, if you're looking for a concept that you can't find, let us know and we'll either send something to you or make some new content that answers your question.